Today I'm going to be going over questions 10 through 15 of the AMC 12A from 2019. With the AMC 12, if you want to qualify for the AME, it's good to aim for around 100 points, and then you're pretty much guaranteed to get in. To do that, you probably want to get at least around 14 to 15 right, and leave the rest blank. With question number 10. This question says, the figure below shows 13 circles of radius 1 within a larger circle. All the intersections occur at points of tangency. What is the area of the region shaded in the figure inside the larger circle but outside all the circles of radius 1? So how do we approach this problem? So first of all, we're supposed to find the area of the larger circle, because then all we have to do to find the shaded region is use the area of the larger circle and subtract 13 times the area of a smaller circle, which, well, each of the smaller circles has radius 1, so they have area pi 1 squared, which is just pi, right? And there are 13 of them, so all the small circles combined have an area of 13 pi. Area of the larger circle, we need to find the radius of the larger circle first. So what we want to do here is to try to form a relationship between the radius of the smaller circles and the radius of the larger circle. So how do we do that? Well, this is the radius of the larger circle, right? So in this distance, what we know is this, which is 2, because it's the diameter of a smaller circle, and this right here, which is 1, because it's the radius of the smaller circle. So, but how do we find this distance right here? Well, we can form a right triangle here, where this distance is 1, and this distance is 1 plus 1, which is 2. This distance, which we'll call x, we can find using the Pythagorean theorem. We know that x squared is 2 squared minus 1 squared, so x is going to be the square root of 3. By symmetry, we know that this distance from here to here is also x, and this distance remaining is going to be 1. So we know that the radius of the larger circle is going to be 2 root 3 plus 1. To find the area of the larger circle, we just use pi r squared, which is going to be pi times 2 root 3 plus 1 squared. This value right here, we can just FOIL that out, which is going to be 4 times 3, which is 12, plus this times 2, which is going to be 4 root 3, and plus 1, all times pi. So this is going to be 13 pi plus 4 root 3 times pi. So this is the area of the larger circle. The area of the smaller circles combined is going to be 13 times pi times 1 squared, which is just 13 pi. So what we get here is just going to be 4 root 3 times pi, or in other words, 4 pi root 3. The answer is A. So this is problem number 11. It reads, for some positive integer k, the repeating base k representation of the base 10 fraction 7 over 51 is 0.23 repeating base k. What is k? So for this problem, we have to convert 0.23 repeating base k to base 10. How do we do that? Well, we know that 0.23 repeating base k is going to be equal to 2 times k to the negative 1 plus 3 times k to the negative 2 plus 2 times k to the negative negative 3, and etc., right? You have 3 times k to the negative 4, 2 times k to the negative 5, 3 times k to the negative 6, etc. So what do we do with this information? Well, let's group the factors of 2 together and group the factors of 3 together. So here we'll have, after this we'll have k to the negative 5, k to the negative 7, k to the negative 9, etc. here we'll have k to the negative 2, k to the negative 4, k to the negative 6, etc., right? And what do we do from here? Well, it turns out that this is an infinite geometric series. And how we sum this is going to be a over 1 minus r. So this sum is going to be equal to a minus 1, a over 1 minus r, where a is the first term and r is the common ratio. The common ratio here is going to be k to the negative 2, and the first term is k to the negative 1, so this is going to be equal to k to the negative 1 over 1 minus k to the negative 2. And this infinite geometric series is going to be equal to k to the negative 2, since the first term is k to the negative 2, over 1 minus k to the negative 2, since the common ratio here is also negative 2. So here, how do we simplify this? Well, we have 2 times this and 3 times this, so let's include that. And so we basically have this equaling to this, right? And how we're going to solve this is we're going to say 2 times 1 over k plus 3 times 1 over k squared over 1 minus 1 over k squared. So we're taking advantage of the fact that we have common denominators already, and basically after that we know that 1 is equal to k squared over k squared, so the denominator is going to simplify to k squared minus 1 over k squared. And the top here is going to be 2 over k plus 3 over k squared. This is going to be equal to 2 over k plus 3 over k squared times the reciprocal, which is k squared over k squared minus 1. This cancels with that and this, leaving k up here. So basically, I'm going to make some room. Hopefully you remember what I did. If not, you can go back in the video. So after that, we have 2k plus 3 over k squared minus 1. And this is already in base 10, right? So we can just set it to equal to 7 over 51. So from here, we can do two things. We can cross multiply and use the quadratic formula, or we can just plug in the answer choices. And I think plugging in the answer choices is a lot easier and a lot faster if you're actually taking the AMC and you're on the time limit. So plugging in, so basically what we want to look for is the numerator being a factor of 7 and the denominator being a factor of 51. So if we plug in 13 here, we get 2 times 13 is 26, plus 3 is 29, it's not a factor of 7. 14 times 2 is 28, plus 3 is 31, is not a multiple of 7. 15 times 2 is 30, plus 3 is 33, is not a multiple of 7. 16 times 2 is 32, plus 3 is 35, is a multiple of 7, so let's try that. If we plug in 16 for k, we have 35. Over 16 squared is 256, minus 1 is 255. And if we simplify this by dividing 5 on the numerator and the denominator, we have 7 over 51, which is what we want, so the answer here is 16. Problem number 12, it reads, positive real numbers x is not equal to 1 and y is not equal to 1 satisfy log base 2 of x equals log base y of 16 and xy is 64. What is log base 2 of x over y squared? So in this equation, in this problem, what we want to do is convert everything to have to do with log base 2, because the answer is in log base 2, this is in log base 2, and it's more convenient if we just put everything on base 2, log base 2. So, for example, xy equals 64. To put this in log base 2, we just have to take log base 2 both sides, which is convenient because 64 is already a power of 2, is 2 to the 6th. So this is log base 2 of 64, which is 6. This also equals log base 2 of x plus log base 2 of y. This is just a property of logs in general. And so going back to the first equation, we have log base 2 of x equals log base y of 16. So what we want to do here is multiply this by log base 2 of y and multiply the other side by log base 2 of y as well. And this works out because 16 is a multiple of 2, and you can basically just use change of base on log base y of 16. So this is going to be equal to log base 2 of 16 over log base 2 of y times log base 2 of y. Obviously these cancel, and you're left with log base 2 of 16, which is equal to 4, since 2 to the 4th is 16. So basically, I'm going to write 4 equals over here. So basically you have all the pieces of information you need to solve this problem with, because log base 2 of x over y is log base 2 of x minus log base 2 of y. This is also a property of logs. And this is equal to log base 2 of x plus log base 2 of y squared minus 4 times log base 2 of x, I'm kind of running out of space here, times log base 2 of y. And this just comes from the fact that if you have, say, a plus b squared, it's going to be equal to a squared plus 2ab plus b squared. And if you have a minus b squared, then you have a squared minus 2ab plus b squared. So basically, the difference between those two is just 4ab, which is kind of the same thing that's going on here with a being log base 2 of x and b being log base 2 of y. So basically, we can just plug in from here. We know this value, because it's right here. This is 6. 6 squared is 36. And this value right here is 4 times 4. So 36 minus 4 times 4 is 36 minus 16, which is 20. So the answer is B. Problems 10 through 12. The next video I'll upload in a few minutes will be problems 13 to 15, so please go ahead and watch that if you're interested. Thank you for watching. Leave a like and subscribe, and I'll see you in the next one.